everybody. There we go. Welcome, everybody, to our event tonight. Thank you, Dr. Kozlowski, for being here. I think this is your second time around. We're excited to have you. Thanks for supporting us.
Hey, good to be here.
Can you hear me?
Yes. Can
Okay.
you hear me? Yeah.
Yes. Did I
Okay, good.
pronounce your name right?
Yeah, it's Kozlowski.
Kozlowski. Okay. Um, Again, thank you for coming to this event and presenting. I just want to go through some quick slides for our own organization. Again, welcome to our members. If you are here for PDH credits, please make sure that you put your name in the chat. Also, please make sure that you did submit your payment for those PDH credits. There was an option on your registration to pay the $10 for that. If you did not pay that and you do not get your credit, you can reach out to us. We will issue you an invoice, but I think that we have worked out an option on the registration where that is a mandatory yes or no answer at this point, where it maybe might not have been in the past. So anyway, you can always reach out to us or me, anybody on the board, to ask us about your pending PDH if you did not receive it. And also, just as an aside, we are a volunteer organization, and as we all have full-time jobs, family commitments, personal commitments. So if we don't get back to you right away, please have some patience. We will get back to you. We promise we will get back to you. And if you don't get the response in the time that you needed, please just keep emailing that email address that we have, liapgpres@gmail.com, and somebody will definitely get back to you. We are not ignoring you. So with that, let me just go through some of these slides. So here are our 2026 LIAPG corporate sponsors. I think there's about 20 on this slide. Thank you very much for every single one of you. This is probably the most amount of corporate sponsorship that I've seen in this group since I've been involved. It's fabulous. It's going to allow us to do the programs that we're hoping to do. We're hoping to do some membership events. We have a scholarship program that we're rolling out. We have the newsletter that we've been doing. So all of these corporate sponsors, you are supporting that. We do appreciate it. If you are a corporate member and you don't see your name on here, please reach out to me. I did update this slide today, but I am only human. So if I missed anybody, it's not intentional. I think I got everybody, but this is great. This is such a testament to our group and to our industry and to what we do. Everybody is supporting each other and supporting this industry and this profession. It's just a really nice slide to see. We might have to break it out into a second slide at some point, but right now I'm still trying to squeeze it all in. So thank you for all our corporate sponsors. Okay, next slide is just basic information. We do have our board meetings in person and online, usually monthly on the first Wednesday of every month. So our next meeting is scheduled for May 6th. Everybody is invited. Please reach out to me if you do want to be involved in that. We can send you a link. We can send you the address or the location that we're having the meeting at. But again, they're both in person and online. I am the current president. Vice president is Chris. We have Cheryl as the treasurer. Secretary is Arnis. And then our current board members, Derek, Jennifer, Olivia, Melissa, Brett, and Lars. So if you have any questions or any suggestions at any point, please feel free to reach out to any one of us. I also want to point out this employment opportunities link. We did have some emails that came in through the last month or so. people looking to be able to post positions, college students looking to post resumes. And so I think we're going to really take a look at that and try to revive that. It's been a little bit of a dead link. But please keep that in mind, because I think, again, that we're going to try to revisit that and keep that updated. Here's our 2026 committees. We have a finance committee, a membership committee, an outreach, a scholarship, event planning, and a newsletter and communications committee. I won't read everybody's name off on here. You've heard me say this before. If you do want to get involved in any of those committees, please reach out to any one of us. You can reach out to the address, the email address for our association, and let us know if you do want to get involved. At this point, I think this would be, I've had some people ask about what's the best way I can get involved in the association. I think these types of committees are probably the best way to get involved and would be the most helpful. So if you are looking to get more involved, please reach out to us and we will hook you up with whatever committee or wherever you think that you might fit or wherever you want to help. We would be so appreciative of that effort. So we have some upcoming events. Obviously we have the Zoom events. This is one of them. We have the quarterly dinner meetings. We're trying to meet every third Thursday of the month. In person is a little bit difficult sometimes because it does rely on the venue availability and the speaker availability, but we do try to stick with that third Thursday of the month. We are trying to plan some sort of a May webinar or field trip. We don't have a date, but I think that there's something in the works. I won't go too much into it because we're still working out the details. I don't want to get anybody's hopes up for that, but we are working on it. June dinner meeting, we're looking for presenters. And as we find presenters or have volunteers that want to present something, we will release that information. And then for our summer, we're trying to plan another member appreciation day at the Long Island Ducks game with the fireworks. I think that was a pretty good hit last year. We're also possibly trying to plan a beach picnic. So watch out for those announcements. If you have any other ideas, please reach out to us. We are definitely open to any suggestions, any ideas. We definitely want to be collaborative. We want to give you what you want. So just let us know. Here's the revamped membership benefits. So we did something a little bit different this year. And I won't go too much into detail about this because I think I've presented this. Oh, it looks like somebody is not hearing. Chris, are you manning the, yes, he is. Okay.
Yes, I am.
Thank you. Okay. So I'm not going to go too much into detail on this. I do want to say that we did revamp the membership. There are some cost savings when you do become a corporate sponsor. For dinner events, you do get, as a corporate sponsor, unlimited membership. You have the opportunity to put an ad in our newsletter, which I think hopefully everybody received or took a look at the last newsletter that came out in March, at the end of March. There are also scholarship opportunities that are going to be provided. And then obviously member events. So if you have any questions about membership, let us know. I think that we're really trying hard to give our members a benefit that maybe we hadn't given in the past. If you have any other ideas or any other suggestions, please let us know. Like I said, we want to give you what you are looking for. We want to make sure that we're benefiting our members as much as we can. In addition to these PDH seminars that we have. So please keep that in mind. Reach out to us. Any ideas, let us know. Some other news and events. So we have obviously the membership renewals are continuing with the restructured format and added benefits. We released the first quarter newsletter. So if you didn't check it out, check it out. It's on the website. If you are a member, you probably also received an email. I'd love to hear some feedback of what you like, what you don't like, what you'd like to see some more of. So if you have any of that, please let me know or let one of us know, and we would be happy to address that. Our second quarter newsletter is going to come out in June. We are looking for content. So if you have content that you'd like to share, please let us know. Again, if there are any students on here and you want to share some research articles or projects that you did, please let us know. We're happy to share that as well. And then finally, we've mentioned this a bunch of times in some of the past meetings. We are launching the Gil Hansen Memorial Scholarship this year. We did reach out to his family and we got really good buy-in and feedback for that. So the announcement will probably be forthcoming in the next month or so. If you have any questions about any of these things or you want to add anything, please let me know. Again, very collaborative. Love the ideas. If you have any. I'm going to turn this over to Chris. This is his slide. He's the current president of the New York Council. So he could share some wider reaching issues with you on this.
Thanks, Regina.
Yeah.
Real quick, just a couple things on the calendar here. There is a New York State Council Professional Geologist student webinar that we're putting together. It's on May 6th at 12 noon. Anything I'm talking about you can find on our website. And the purpose of this is that part of the council's mission this year is to begin to really strengthen our outreach, connecting the academic and student community with the professional community. So what we've done is we've sent out invitations for this to, I think, 42 universities across New York, hoping that some students will get some interest in. It's going to talk a little bit about, and you can see in the flyer in the corner, it's about licensure, and then we've got some segments about what it's like to be a professional geologist and what do we do in our daily course of life. So you can check that out. Anybody's welcome to join. You can just register through the website. There is a course that Midwest Geoscience is putting on, and they've been very collaborative partner with the council through the years. It's at Vassar College, and it's on May 13th, 14th, and 15th. The first day is about improving boring logs and well construction logs, and the remaining 2 days is about contaminant transport in fractured systems. So if you're not aware of it, you might want to check it out. It's a good program. We have geology days scheduled for November 11th through the 13th. Most probably everybody on this call is familiar with what that's about. But, we are in the process of receiving abstracts. There was a call for abstracts that went out. The period is still open and we're still looking for presenters. So if you have a really cool project or a presentation that you made before that you think you'd like to do again, go to our website and consider submitting an abstract and for consideration. There's a QR code in the upper left. You can check us out also on LinkedIn and follow, organizational events that are posted there. We're operating with an updated, new and revised website that's more user-friendly. I think you'll find it exactly that. And similar to LIPG, we have a quarterly newsletter, and we are always also seeking content and contributions from the public at large. The last thing that's not on this slide I want to mention, there's probably a lot of people that are seeking PDH credit, and there's a good one coming up. Fred Stum, probably a lot of people on this call know him. He's with the USGS, longtime career man. He is a friend of LIPG's and the councils. He recently just did our LIPG last dinner meeting last month and did a great presentation summarizing many, many years of his work with his colleagues. at City College on the 28th of April. He's doing a 2-hour, 2 PDH credit presentation on borehole geophysics. It is available in person for anyone, or there is an online option to do it as a webinar like this. And you will see a email blast if you're part of our contact list advertising this in the next day or so, with a link to the registration page on City College's website. I will just say this and close that I did array register. It's free, and it was pretty simple. So if it's something that interests you, check it out. Fred's very proud of what he's doing, and we are, both the council and LIAPG are very proud to say that we have heard from City College that they want to be more proactive in outreach in the opposite direction to connect their students with the professional community, and they're really doing a good job with it. So you can see more of that content on their continuing education page. With that, I'm going to turn it back to Regina. You're muted.
Sorry about that. So thanks, Chris. With that, I'd like to turn it over to Dr. Kozlowski. So maybe, Chris, I could stop sharing my screen. Oh, before we do that, I do want to just say one thing. As far as PDH credits go, if you are seeking one, you do need to stay on this presentation for the duration of it. There will be a Q&A session at the end. We do ask that you make sure that you participate in that, put some answers in for those questions sessions so that you can get those PDHs that you need. If you have any questions, if you think that you signed up for them and you don't receive them, again, reach out to one of us. We will go through the log. We do keep a log, by the way, of the chat and of people's attendance and the times that they're on for the duration of the presentation. So if there's any questions that arise, if you don't think that you got your PDH and you needed to, please just reach out to us. But again, just make sure that you have your name in the chat and you stay on and you participate on the Q&A so that you can get those PDHs. I think with that, I'm going to turn it over to Dr. Andy.
Yep, and Andy needs to share. And I'll just say while he's transferring that at the end, when we have Q&A, questions from the general audience, if you off mic and ask the question directly, and if you're shy, you can put it in the chat box and I'll read it for you.
Can you see my screen? I was sharing earlier.
Not yet. We're seeing your camera view.
You see it now?
Not yet.
Okay, let me close out of this. I'm in presentation mode. All right, back to share. Okay, you see it now?
Bingo. Put it in full screen mode and you can rock and roll.
Okay, here we go. All right, thank you, folks. Thank you for the invite. Again, I'm Andy Kozlowski. I'm with the State Geological Survey, and there it is. All right, up in Albany, and with the State Museum, and I'm a research scientist as part of the Geological Survey, and my area of specialization is on the Pleistocene. So studying the last ice age or several ice age, and primarily I work through geologic mapping. I have a background in hydrogeology from my graduate degrees and geologic mapping for Pleistocene stuff, and was lucky enough to come to the museum here in 2006 and have been doing mapping and work on this since. We operate under, like, sometimes people say, hey, how come you're not out like chasing contaminants or something? And we actually, our legislative mandate that we operate on is this State Science Service law, which is part of the State Museum. And so a big component of what we do is described or sort of set for working on natural history issues, as well as developing geologic maps that can be used by a variety of professionals, including the professional geologic community, which is our sort of the group we try and target the most with our work. Boy, that is wacky. Okay, so as part of the work we do, again, we produce a large number of geologic maps and work. This is a link that you can find our map publications. They're all available for free for download. Many people are aware of this, with these maps, but you may have to go to our museum website, but you can always email me or my colleagues to find out what we have available. And we've put out a ton of maps, more maps in the last 5 years than we have in the previous 40. So we're kind of rocking in that regard and trying to get as many out as we can to help people out. Tonight's talk is going to be focused primarily on the Hudson Valley and the lower Hudson Valley, looking at moraines and some other landforms and some recent work that we've been looking at in the Pleistocene. So that's sort of an overview focus area of what we're talking about. And again, all of this work is primarily sponsored by the USGS through the State Map Program and the Great Lakes Geological Research Program. We've had some other collaborators from Illinois Geological Survey for some of our geochronology dating, but we wouldn't be where we are if we didn't have the support of the USGS supporting the State Geological Survey. So tonight we're talking about the Pleistocene, which is, again, a relatively recent time frame, geologically speaking. This diagram is showing on the screen is showing us geologic time on one axis, latitude on another, and temperature on the vertical axis. And of course, we're all probably aware that the Cenozoic was a time of global cooling. And in the last 5 to 6 million years, the climate got really crazy and put us through a series of numerous ice ages, triggering the Pleistocene about 2.6 million years ago. First glaciation in New York probably happened in the very late Pliocene, is what we're kind of hypothesizing probable. Again, Pleistocene. So ice ages in New York State and in the Great Lakes region have been talked about in a number of different sort of ways or described. A lot of times there's older terminology that will kick around, such as, Wisconsin or Illinois glaciations and so on and so forth. We may have learned as undergrads in school. The more recent work is developed out of looking at marine isotope stages and the deep sea benthic cores. So in this diagram here, we have basically, this is from the deep sea cores benthic diagrams. And basically we can, if we look at the uptick on these white spikes, those are representing times of global cooling. And there's so many of them basically that we've identified from ice cores and benthic cores that we used to just sort of have 4 glaciations, and now we've recognized that it's far more complicated, so they're numbered primarily. Even numbers are cool periods or global cooling glaciations, and odd numbers are interstadial or perhaps interglacial timeframes, as we list them again. We refer to these as NYS cycles. And we know that there's been about 102 of these in the last 2.6 million years. And to sort of tie the bridge from some of our older terminology into these NYS cycles, the NYS2 cycle was the late Wisconsin glaciation. It's a time when New York was supposedly covered by the last major ice sheet. There's debate about the middle Wisconsin and the extent of ice, and also the early Wisconsin and the extent of ice in New York State. And we know that during stage 6, the Illinois glaciation, ice covered all of New York all the way into parts of Pennsylvania. And so tonight I want to share with you some of the research we're doing, because we're trying to decipher and understand not only the more recent glaciations, where we have the most complete record, and it's complicated enough, but with some of our other work through drilling and coring and stratigraphy, we're trying to figure out these earlier cycles of glaciation. So we know from the published literature that we have for New York that the traditional map for New York State shows all of New York State being glaciated by the Laurentide ice sheet during the last glaciation. This is the stage 2 or MIS2 timeframe. And that ice sheet was not a static block of ice, right? We're becoming more and more conscious of the fact that the glaciers themselves were very dynamic, perhaps moving around. And so this diagram is showing us these traditionally interpreted flow lines of the different lobes of ice coming out of the Ontario Basin, traveling down the Hudson Valley, circulating around the Adirondacks, making their way all the way down to Long Island, into the terminal moraine into northeastern Pennsylvania. And again, the traditional maps by our colleagues in Pennsylvania have mapped the terminal moraine all the way into Pennsylvania. This is work that goes back a really long time along those lines. So since I'm talking about glaciers a little bit, let's just review a little bit. Again, this is very rudimentary or precursory. So again, the glaciers are forming because the climate's changing. We're accumulating massive amount of snow. Snow is crystallizing into ice, and when it accumulates to a thickness greater than 50 meters and begins to fuse, the ice will begin to move under the influence of its own gravity and form glaciers. And as from the zone of accumulation down to the terminus, zone of wastage, the ice is flowing from high to low, lower state of energy. The best analogy I use for talking to school groups is pancake batter. So the next time you're making pancake batter on a Sunday morning, think about it. You're sort of watching glaciers grow and flow, if you will. The glaciers leave telltale signs on the landscape of where they have been and very certain landforms associated with that. So the ice again is, bringing up material from the base of the glacier, transporting it through the glacier and glacially bringing it to the surface, and dumping these materials, depositing the materials in front of the ice and around the ice near the terminus, and creating a host of landforms, primarily that we think of and know of as moraines. Sometimes they're big ice contact deltas because the ice is flowing into lakes or something like that. But this is sort of the very generalized model of sort of ice movement, how it entraps debris from the base of the glacier and brings it to the surface, and then will deposit these types of landforms. There's a whole host of different types of moraines that can be found on the landscapes. Depends upon a lot of factors associated with the glaciers, whether the glaciers are cold-based and frozen to the ground, or are they wet-based and have a warm fluid base with water flowing underneath it. And the landforms that result can be sort of thrust, structurally deformed landforms in a foreland, or they may just be simple ridges left along the landscape depends on the type of activity and the type of basal thermal conditions that are happening at the base of the glacier. There's a hypothetical scenario of seeing glaciers in a sort of a more alpine or valley sort of configuration, with, again, the terminal moraines or the outermost moraines, and then recessional moraines, and then the sides where the ice is conforming to the valley profiles is where we find these laterally constrained or lateral moraines, which are under the influence of topography. When the whole landscape is not covered by an ice sheet, right? A continental scale glaciation covers all of the topography, which is what we believe to have happened in New York State. It's the primary belief that's sort of been out there. During deglaciation with retreat, one thing that's really kind of amazing in New York is we know that there's lots of ponded, trapped water because the glaciers interacting with escarpments and bedrock topography. So we have a host of very large lakes accumulating around the state during deglaciation. This is sort of a hypothetical, or basically this is what it might have looked like in New York 15, 16, 18,000 years ago in some of our larger valleys, with ice calving off a large ice sheet constrained by valleys, so on and so forth, and the depositional environments associated with them. When we have ice that's trapped in these proglacial lake systems, it's doing a variety of different depositional mechanisms. It's building these grounding lines or morainal banks in the subsurface. It's, you're having rainfalls, you're having iceberg, ice rafting, and a host of these different types of sort of sedimentary processes that are associated with ice interacting with a proglacial lake environment. Should be no surprise then that we're also building really common basic landforms like deltas. And these deltaic deposits have, again, bottom sets, foresets, top set types of depositional systems that can tell us basically what the glaciers were doing, and can be used to interpret and infer the previous lake heights and levels. The datum is basically where the foresets and the top sets meet. Often is sort of a reflection of the previous height of paleo lakes that were present. So this is a slide that was taken last year at the Northeast Friends of the Pleistocene trip in Massachusetts. It's a great slide of a delta. And so you can see the four sets in the midsection, and there's obviously a break in the contact between the upper units and this middle sequence of units. So you've got top set beds, four set beds, and again, that contact there is basically telling us where the lake level was previously on that slide there. So we can infer and interpret these landforms and these deposits as we're working to understand these previous previous glacial conditions around the landscape. Again, so taking us back into what we know or the general consensus, this is a publication that's come out in 2023 by April Dalton and her colleagues looking at the last glacial maximum. It's been a hot topic of sort of work in the last 4 or 5 years, actually last 10 years, to try to understand this. There's differences in age between that have been dated from the ice margins in the Midwest and Illinois and Wisconsin to the ice margins in New York. And there's interest in understanding why these ice margins may have varied or the dynamics associated with that. And this is true in New York, particularly in the lower Hudson Valley as well. So you're probably all very familiar with the geological maps that were produced by the Geologic Survey in the 80s and the 90s. This is the Hudson Mohawk sheet. It's 1 to 250,000 scale. It was produced by my predecessors, Don Cadwell and Bob Deneen, here at the State Museum and State Geologic Survey. And again, different colors represent different mapping units, so on and so forth. Yellows and oranges are typically clastic glacial fluvial sediments. Pinks are till units, and red on these maps is bedrock. Lake clays are represented by the color brown, the valleys, so on and so forth. On these maps, they did some preliminary work to map out hypothesized ice margins, and a lot of this work was done on the basis of original topographic maps and work that was done from really the 18th and 19th centuries here in New York when they were first starting to work on these things. So this is the ice margins in the lower Hudson Valley. And if you have these maps, you look on the sides and the legends, these ice margins are printed on these overall larger regional maps. And these maps are still available, by the way, these map sheets, if people want them. We have zillions of paper copies. So just send us an email and let us know. We'll send you them for free. Same thing with the lower Mohawk and the Long Island area as well, as the map sheets are available, and they have the ice margins and sort of a precursory geomorphic history and geologic history of the state, so on and so forth. And again, they highlight the map units, different colors, so on and so forth. And then it's just a map showing you the ice margins that have been mapped out, again, largely off the basis of topographic maps when this is being done. So other work to understand the deglacial chronology of these ice margins in the lower Hudson Valley and around New York has been done through a variety of different techniques. The one that's been worked on for the last really 20 to 25 years by Jack Ridge out of Tufts has been reconstructing, looking at varves and the New England varve chronology. So this image here is from Jack Ridge and his reconstruction of the deglacial margins as they're retreating back from south to north up the Hudson Valley. And he's got these ages. These ages are radiocarbon or sort of chronologic years that have been sort of correlated with some radiocarbon dates, but primarily based off of the New England varve chronology. In his publications, he lists these moraines. And so this is sort of the basis for our understanding of some of our deglacial chronology that's been done. Tonight, I'm going to talk to you about a new discovery of a new moraine that is oriented in a fashion that is, most of the moraines oriented sort of a perpendicular ice flow. This one is oriented sort of in a northeast to southwest or north to south orientation. I'll talk about that more and how it ties with some of this previous work in the lower Hudson Valley. So this is the Heartwood area, which we'll talk about later. One of the general consensus of dates, again, a lot of work done on this, is a variety of different types of studies that have been done on using different techniques. And I'll talk a little about the techniques in just a moment. This is a paper from 2017 by Lee Corbett and her colleagues, dating using a cosmogenic radionuclides to sort of date the moraines. And this trend saw this debate because there has been debate about the age of these moraines. And so again, typically we think about the terminal moraines on Long Island and New Jersey and these areas being around 25 to 28,000 years of age. And so that using these new techniques to try and constrain and refine the understanding of the age of these terminal moraines and these moraines in the lower Hudson Valley, Long Island, northern New Jersey's areas, so on and so forth. So this 25,000 is a good number to think about for the terminal age of the terminal moraine in northern New Jersey. And same thing, Scott Stanford, who was with the New Jersey Geological Survey, really did some outstanding work down there to help try and resolve these, and came up with similar ages based on some radiocarbon data and some other work that he was doing at around 25 to 24 for the last glacial maximum moraines down in this area. But the debate has centered largely around the concept of radiocarbon dates versus these other cosmogenic dates. And the work sort of stems back from a paper that was put out in 2012 by Dorothy Petit, who was dating bogs and wetland surfaces down in the lower Hudson Valley, and looking to date plant fossils, sort of find real datable material, and looking at older dates that have been published in bogs and wetlands and so on and so forth in small lakes, looking at sort of bulk older radiocarbon ages, comparing the older radiocarbon ages from the 70s and the 80s, and collecting new radiocarbon ages, and sort of trying to plot this up. And part of her research, which she was doing, was this sort of that there was a discrepancy in the ages between her radiocarbon dates and these cosmogenic dates that were being found in the lower Hudson Valley was taking place. So this is part of this debate and this age as to sort of what is the age of deglaciation. And what she was actually proposing was that there was a delayed deglaciation, perhaps that there was so severe tundra conditions that there's no vegetation growing on the landscape, and that's why they can find very little stuff to date through radiocarbon dating. And that's why there is a discrepancy between radiocarbon ages versus this other cosmogenic process, which is dating boulders and other materials on the landscape. So that's kind of part of the debate in the background. A more recent paper from just a few years ago was, again, a process looking more at these more recent cosmogenic dating methods down in these areas, collecting samples again from, again, Long Island, northern New Jersey, looking back up around the Harriman State Park, the Pine Island Moraine, places in the lower Hudson Valley, and a lot of work sort of building off of work that's been done off in New England on Martha's Vineyard, so on and so forth. So this is this more recent paper from Balter Kennedy with these ages again. These are sort of cosmogenic ages that are being proposed, and I'll circle back to this in a little bit later. So again, focused on primarily Western Long Island, Northern New Jersey, because that's sort of the area that ties in with New York State primarily, and the work we've been doing. So just as a general overview from a smattering of a variety of topics, is that basically the general consensus is that the last glacial maximum terminal moraine is somewhere between maybe 21 and 27,000 years ago, is the sort of general consensus where people won't sort of get into an argument about that broad frame. So again, as I mentioned, the methodology behind making a lot of these earlier assumptions was mapping moraines. We all grew up, or we learned, most of us in our undergraduate classes, we worked from topographic maps, looking at contour lines and trying to understand the landscape from this concept. But this has evolved significantly and really been an impact for our work. And so we moved from topographic maps and topographic base to using a LIDAR. If you're not familiar with LIDAR, most people probably are, but LIDAR is using laser altimetry. Basically, it's a signal coming off of a plane that can basically send a return out. The return hits the treetops. Part of the return, a second return, hits the surface. They can subtract the vegetation from the treetops and then end up generating basically what's called a bare earth surface. So they're basically removing the vegetation. And so this is just an example of this LIDAR terrain methodology where they're able to sort of remove trees, and you can see the surface. And so in this case, this is from an archaeological project where they can see there's obviously this rectangular feature that was some sort of a settlement or a fort, I think, of the Iron Age. So it's an incredibly powerful tool to see the landscape in unprecedented detail. And it has revolutionized our ability to look at the glaciated landscape and see new details. And so as an example, this is from Auburn, New York, up near the Finger Lakes. And in these LIDAR images, we can see a host of glacial landforms. We can see moraines, which represent where the glaciers paused and built the moraines on landscape. We can see drumlins. And you can see the resolution is so fine. You can see the city blocks within the city and the structures themselves and the main roads and the infrastructure. So this has really revolutionized our ability to look at these landforms and target new areas for investigation and study in the superficial geology left as a result of the last glaciation. So our first question is, for your group, which type of technology allows geologists to see improved, higher resolution topographic details on the Earth's surface? The choices are reading glasses, 1 to 24,000 topographic maps, or LIDAR. And I'll let you sort of pull the audience there, submit your answers. And our answer is choice C, the LIDAR technology that I just mentioned. Okay. Other developments in technology that we're using include new methods of scientific coring. Again, this is really your wheelhouse. You're the experts on the ground doing site characterization, so you're familiar with a large variety of this, the direct push, sonic drilling, so on and so forth. And the last one that we're using now is this wireline soil coring, which you may or may not be aware of, but soil coring it's basically very similar to bedrock wireline coring, which has been around since the 40s and the 50s. Except that you can actually do this with unconsolidated sediments as well if you are set up and have the right drillers and the right approach to doing this. It's not easy, but we can recover really some amazing stratigraphy, Pleistocene stratigraphy, if we are dialed in and doing it correctly. And again, we use our drilling art to reconstruct our depositional environments and characterize and sort of reconstruct where we are, whether it's glacial tills or stratified outwash or fine silts and sands, fine silts and clays, tells us where we are depositionally in the previous environments, paleo environments, so on and so forth. When drill rigs don't work, sometimes we will go in and get to places where the drill rigs can't get to and core upland basins and wetlands and places like this to sort of look to see if we can record cores by hand. Those hand-driven cores in a lot of places can recover very delicate cores. So this is one of our cores that we've covered with that Livingston coring method that we're just using there. These little black streaks are, again, the plant macrofossils that are in these cores. We'll look at those again in a little later in the talk. They look like black streaks, but if you spend time in the lab, you can actually extract them, and it turns out that those black streaks are actually plant macrofossils. And pretty much these are tundra plants that are growing on the landscape. These ones in the slide here are about 16,000 years old. So the two plants at the bottom of the slide here, the one on the left is Dryas integrifolia, and again, the one on the right is Salix reticulata. And so these are sort of the two primary tundra plants that I look for. Am I a botanist? I get this question a lot. Did I take botany classes? I did not take botany classes. We have botanists here in the museum, and I paid attention and asked them questions, and they taught me what to look for. So people, again, how do you know what to look for? Because I can tell the difference between a pickup truck and a sports car. And that's pretty much as far as my botany skills have to go. I know the 4 or 5, 6 plants that I need to look for in the cores that are sort of consistently there. And so I'm really trying to look for these tundra plants that would have been growing in cold climates. Radiocarbon dating. So radiocarbon dating, again, you're familiar with it, probably, again, from undergrad or so on and so forth, but is, again, radioactive isotopic decay that we use to date things. We can date things back to about 50,000 years, and then we run out of half-lives to really get adequate resolution. Again, everything is taking in that's alive, taking in C14 through eating plants, animals, so on and so forth. These things accumulate in our bodies or in living tissue, and then can back it out through, again, if it's younger than about 50,000 in age, we can sort of pull out and measure what residual carbon isotopes are left and then use that. So here's an example of a tooth that was recovered from the Erie Canal when they were building the locks up near Montezuma, the wetlands. Again, that's sort of the location where this was found. And so the radiocarbon ages are presented in a radiocarbon data set. It comes back as 14C. This is the results that come back from the lab results themselves. But the atmospheric concentration of carbon-14 has not been constant throughout the Earth's history. And so when we get an actual radiocarbon age, we have to calibrate that radiocarbon age to sort of figure out what the true age is on the samples that we look at. And so to do this, we use a program software. This is the predominant one to use, is called Calib. And this will it's been developed by people to calibrate radiocarbon ages into a calibrated radiocarbon age, sort of through this process. And so, again, look back at that same sample, and there's our radiocarbon age. We would throw this into the Calib, and the Calib software would tell us basically that our range of ages would be basically between 13.4 and 13.7 calibrated age, taking into account for these C14 atmospheric fluctuations. So how should we report these calibrated radiocarbon ages? We report them again, typically in this full range, 13.4 to 13.7. And we usually report a median age, which is put out by the software, this Calib software. So we report this as 13.6 Ka as a radiocarbon age. And again, we can date this pretty much, again, these samples from 12,000, actually much more recent than that, to 53,000 in age. And they typically have a precision of somewhere between 50 and 200 years. And so generally speaking, radiocarbon dating gives us this highest degree of precision with our existing geochronologic methods. Again, highest degree of precision in our existing geochron methods. A couple other things about interpreting radiocarbon ages from different depositional stratigraphic scenarios. We can use the context of radiocarbon dates to understand this. So a lot of times we target wetlands or sites to look for these radiocarbon ages, such as upland basins and these small ponds or lakes, high on the landscape where they're not going to hopefully get lots of sedimentation, so we can evaluate the sedimentary record since deglaciation is kind of the trick that we're up against. And so if the basin happens to have some organic material deep in the basal sediments, and we can core these sediments again, we can recover a twig or a plant macrofossil, as I've shown you before, and we can interpret that age. But what is that age really telling us about the landscape and the landform, and how can we use it to constrain Pleistocene events? Well, we can understand that basically, again, the basin has to be present before you can put sediments into it. And so the plant fossils are really giving us information that's telling us about a minimum age for the basin, okay? So a lot of times people will talk about a minimum age. So the basin just had to be there before deposition and the fossils could get washed in. So the basin could be older, but it can't be any really younger than the radiocarbon age that we are presenting from these from these basins that we're looking at again. There are considerations with any stratigraphic radiocarbon data we get. We don't really know. We have to make sure that the stratigraphic order, hopefully, have more than one radiocarbon date, so we can see that the age is maintaining superposition and things are getting older with depth. That we haven't had lots of fluctuations where materials could have been washed in from higher elevation terrain and might be reworking wood or some other durable type of material. And there are also places where we have to be cautious because we can have kettles on the landscape where ice blocks have melted and there may have been a lag in deglaciation, sometimes up to 2,000 years or so between these things deglaciate and then when organic sedimentation can begin to accumulate in these basins. So that's the upland basin scenario. The other scenarios, if we're talking about stratified sites, such as a till site and buried valley scenario, and in this scenario, we can have twigs that are incorporated either in the till unit or directly under the till unit, and maybe a buried sedimentary sequence or something like that. And in this case, it's a different context. The twig or the woods that we would see in the till unit underneath it are providing us a maximum age for the till unit, telling us that the till unit can't be any younger in this particular instance. So depending upon the context and the stratigraphic framework we're looking at, we can use radiocarbon dates with a pretty good degree of understanding to help us figure out the stratigraphic context or the landform sequence, if you will, on the landscape as well. Other methods that we utilize are included optically stimulated luminescence, known as OSL dating. An OSL dating is dating quartz. We can date sand grains. We can do this pretty well as long as the sand grains have been exposed to sunlight. So the easiest and simplest way to sort of explain this when I talk to people is that the sand grains at the surface, if they're transported by a particularly good method, is wind-blown sand dunes. The sand grains are flying around. They're getting stimulated by solar radiation, and the quartz grains particularly are getting stimulated. And then when they're buried, they're no longer being exposed to the sun. And so that stimulated or luminescence charge that they accumulated is beginning to decay because they're now buried and not being recharged. And so the decay of this solar luminescence signal in quartz grains can be measured, and it can tell us and give us a burial age to the age of the sand. Now, it has to depend upon how well the sediment has been bleached. So again, sand dunes where it's been blown around and really worked well is great. Places where it hasn't been transported that far, or it's been transported in the bottom of a lake and it never saw daylight, has to be careful because they may not be fully bleached and you could have sort of inheritance ages that are going on. So we collect these samples with this conduit or plastic pipe into the outcrop. We label them and tape them up. It's a colleague from USGS, and we send them off to the lab, and they will do sort of a single grain or multi-grain analysis looking at these quartz grains to sort of date these burial ages again. You can use IRSL, which is looking at the feldspar instead of quartz, and you can look back much, much further. OSL looking at quartz is good for about 100,000 years and younger, really quite reliably. But IRSL looking at feldspars can go back much older in age. And we have colleagues in Minnesota that have been finding materials that, again, are as far back as MIS 12, 400 to 600,000 years old. So really helping to revolutionize our understanding of early glaciations in the Great Lakes region as well. So our typical OSL precision basically is not nearly as good as it is the radiocarbon dating. And we can sort of reliably say that a sort of 2 sigma precision age range, statistically, that's the 95%, is somewhere between 1 to 4,000 years of age, sort of a range depending upon how well it's been bleached and the quality of the samples we're looking at. And again, going back through. And the last method I want to mention here is this cosmogenic dating method. And this is very basic. This is not my expertise at all. I'm working with colleagues that do this, but it is a real growing technique being used to date glacial landforms. And this is using, again, the most common ones are beryllium-10 nuclides. And again, this is sort of, again, solar cosmogenic nuclides coming down. They are interacting with bedrock surfaces and rock surfaces, and ideas that there is enough erosion or material that basically that the erosion from glaciers removes any older or sort of a rock layer so that they're freshly exposed, and then the rocks are transported by glaciers. They're put up on a landscape, a landform like a moraine, where they're sort of situated and perched up high on the landscape. And then from that point in time, they're being re-stimulated or getting new cosmogenic exposure, and they can measure this exposure age. And then with enough boulders, they can tease out and estimate an age for these cosmogenic ages on the landscape. So the best case scenario is the ideal scenario is, again, they're sort of accumulating on these moraines, and they've got a well-clustered grouping, and there's no inheritance left over from basically ineffective erosion or something like that with time. Along those lines. The cosmogenic ages are ranged between again, their full 2 sigma confidence is somewhere between 500 to 2,000 years. So the cosmogenic dating might be a little bit better than the optically stimulated luminescence, but not as good as the radiocarbon. So the radiocarbon dating is probably the best method to use for these dating methods in our current toolbox, if you will. Which brings me to our next PDH question, which is, which of the geochronologic methods I've discussed gives us our highest level of precision and confidence for understanding the glacial landscapes? Your choices are, again, cosmogenic exposure of boulders, OSL dating on deltaic sands, or AMS radiocarbon dating on tundra plants. And their choice is choice C, AMS radiocarbon dating, which has greatly improved in the last 15 to 20 years. Okay, so with that background, let me just dive in and talk about our first case study, which is this Heartwood Moraine. Our Heartwood Moraine study is an outgrowth of work that we did for the National Park Service. The National Park Service owns about 30 acres along the upper Delaware River Basin, and they asked us to come down and do mapping on their area. So they own a very small part of the land, but they are deeply involved with the regulation of the upper Delaware River Basin. And so they wanted some extensive mapping, superficial geologic mapping done along the upper Delaware Basin. In the process of doing that and looking back in this region in the LIDAR, we made kind of a sort of astonishing discovery in our sort of estimation here on the landscape. So just to sort of review and talk about these moraines, these are the existing or known moraines that we've known about for a long time on Long Island and the Lower Hudson, Harbor Hill, Ronkonkoma Moraine on Long Island, the Pine Island, Wallkill, and these Rosendale margins in the Lower Hudson valleys. And the area we were working on was to the west of the Basher Kill, over near the Neversink and along these areas. And in this particular area, you can take a look at this slide. You'll see there's a small yellow, I'll zoom in, yellow and red ice margins that we mapped out as part of our mapping process on the landscape. And this is the Heartwood moraine that we have found. So this is the sort of position compared to the other moraines that are here on the landscape. Again, they're not mapped. You don't appear any maps. The larger scale. This is about sort of 2 or 3 years old from the work we did 2019. The Heartwood moraine, and then there's a smaller recessional moraine behind it. We found this only because of the LIDAR. And so this is a LIDAR image of our Heartwood moraine on the landscape. It's about a half a kilometer in width. It was this sort of very pronounced ribbon following the edge of the uplands in the southern Catskills. We can trace it for quite a long distance up near the Neversink and along these areas. We first saw this thing was sort of like, what is this on the landscape? Is it some sort of a structural feature? We weren't really 100% sure that it was necessarily moraine. So we went down again and did our due diligence with our boots on the ground field mapping. And we think that it is a moraine, and we think that it marks the western edge of the Hudson Lobe, which would have been the main glacier in the Hudson Valley during deglaciation as ice was beginning to recede back and melt back. This is another sort of not colored picture of what it looks like. You can see to the right of the slide, you can see very clear stacked sort of bedrock that's got sort of a tableland or mesa, almost sort of bench-like stratigraphy and topography. So you can see the bedrock on the side, and you can see the moraine, that's sort of the central part of the screen. It's got fans and other features associated with it. And you really know it when you're on the ground because you'll break your ankle. So this is what the ground looks like on the moraine. It is just absolutely boulder strewn on the landscape. Great place to drag sleds to try and get in and do field work. It's full of rattlesnakes in the summertime, so which is why we're out in the winter walking around when we could. And we produced, again, a geologic map in this area for the Heartwood moraine. This is part of our mapping efforts. Again, this is a newly published map to the Geologic Survey, and that sort of tan-colored area is the moraine that has been mapped. So as part of this work, we were really curious about how old this thing was. And so we looked back on the landscape associated with Heartwood moraine, and all the way to the south, closer to the Mon Gap and the down by the Delaware River. We zoomed in. We noticed another feature associated with the Heartwood moraine, a sort of high elevation or higher elevation flat top landform with a quarry in it. And we were able to get this owned by the town. It's on your Wilson. We also the Wilson site location. And this is basically a delta. It's a delta that was building into a glacially dammed or ice dammed lake in the Neversink area in the Delaware River Valley. So these are deltaic sands, foreset beds. And when we got our OSL samples and the sand units, to our surprise, they came back substantially older than we were expecting. In fact, they were so surprising and so shocking that we went back and I collected additional samples and I sent them to an entirely different lab without telling my colleagues because I wanted to see sort of the results. And the results we came back from redundant samples from a completely different lab showed us that they were much closer to 25,000 years of age for the top set of the uppermost units of the delta, and older sediments below that may or may not be fully bleached. They may be, we're not sort of certain about those, the deltaic, the foresets, but the top set units are typically pretty solid for OSL dating in most sites we've worked with. So that was odd. And so the next thing we want to do is come back and see is there another way we can date this moraine, taking a look at it on the landscape. So this fits in with this other regional feature, which you're probably familiar with, which is the Shawangunk Ridge, which is, again, some spectacular geology of its own. And the upper sections of it consist of these quartz pebble conglomerates, which are a really neat bedrock unit. But they turned out, for our idea was that we were walking around those moraines on the Heartwood moraine. We noticed that every once in a while we would find a boulder intermixed with primarily all just regular sandstones. And every once in a while we find a boulder that had these pebble conglomerates associated with it. So we sort of decided to go back and sort of beat the ground, beat the bushes, and see what we could find. And so we went on sort of this massive boulder hunt around the moraine to identify and see if we can locate these pebble conglomerate quartz-rich boulders. And we were able to find about 9 of these boulders sitting in positions on top of the moraine, deposited by the glacier. and collect these samples and then bust out the quartz pebbles, these milky white quartz pebbles, collect them and send them off to colleagues at the University of Buffalo that are cosmogenic experts to take a look at these things. So this is just another example of sort of these boulders sitting on the landscape. Tried to find the biggest ones we could that wouldn't have been moved by a farmer, but no farmer was dumb enough to try and farm this terrain. It's just boulders thrown, as I've indicated before. So what is the age of the Heartwood Moraine? Well, we got 9 of these new cosmogenic ages, and they all came back between about 20 and 23,000 years of age. And so that fits in showing that these older, this is the diagram from before from Balter Kennedy 2024. The red sort of drawn in diagram on the left of the screen is showing the approximate location of the Heartwood Moraine. And so our optically stimulated luminescence or OSL dates say about 25, and our Cosmo dates are saying 20 to 23. So we can say confidently, probably, that the ages are somewhere between 25 and 20 Ka, and it may tie in with the last glacial maximum and early deglaciation. That again, there's no previous literature on this feature on the landscape, so it's a pretty new. We feel it's kind of a significant discovery down in this part of the world. Also down in this part of the world is the story of another discovery that happened just last year that is about mastodons. And so as part of the Ice Age story, we know that there are megafauna all over the landscape, found in many places around the Great Lakes and also here in New York. But in particular, in New York, we know that lots of sites have been found for these mastodons, but one stands out. We've been about maybe a couple hundred mastodons have been found in New York in total. And again, that's not really my expertise. I've got a colleague here that's a vertebrate paleontologist. But Orange County turns out, the hot spot. Orange County has the highest density of mastodon fossils of any county in the United States, which you may or may not have known. I certainly didn't know that until I came to work at the State Museum. And so every once in a while, a mastodon turns up through a construction project, or a farmers usually find them digging tile, putting in tile, or digging drainage ditches, or something along those lines. And so this is one from 2009. A couple guys canoeing in the Wallkill find what they thought was maybe a tusk sticking out of the bank. Lo and behold, we got permission from the landowners, came through and did an excavation, and were able to recover not one tusk, but both tusks from a mastodon that dated back to around 15,000 years of age. It's really kind of a really neat project to be involved in. And then that was it. Hadn't heard much. And then last year, basically, my colleague got a phone call about a new discovery, which happened down in the Middletown area of Lower Hudson Valley area, where a gentleman was out doing yard work in the fall of the year and literally moved a bush aside on his yard and discovered, sitting there at the ground surface, a very large molar that he thought was maybe a tooth for a mastodon, and contacted some folks at Orange County Community College that put him in touch with my colleague at the museum, and that sort of launched this next adventure, if you will. So relating it and tying it back into our story of moraines and mastodons, the one that's highlighted there on screen is the Pellet Island moraine, which is estimated to be around 18,000 years of age. Over near Otisville, and near the Schwangunk Ridge, there was a site where a mastodon was recovered. And in that site, there was some organic sediments that were collected in this area, radiocarbon dated, suggesting around 1704 for a radiocarbon age. But this was on sediments. It was not on really actually organic material. It was sort of just bulk sediments. And bulk sediments aren't always necessarily really reliable targets for radiocarbon dating. But this is sort of the information we had available, aside from the existing new cosmogenic dates that are being collected in the region. And so again, there's the ridge talked about before, but in this general area here is where we'll zoom in on the next series of slides with LiDAR to really help us dial in. And so again, the LiDAR is just spectacular. You can really see all the drumlins and streamline landforms in the landscape. And a number of upland basins that are around the area, and you can see the whole development. It's highly developed. But here again is where someone made this discovery, and we got fortunate. They reached out to us in the museum. So the gentleman in the center with the white baseball cap is my colleague, Bob Franick, who's our vertebrate expert here in the museum. This is part of a student archaeological project that developed as a result of this last year, where they're excavating out portions, looking, and they found additional remains. So in the bottom earth section where they're working, you can see something there. Those are ribs from the Pleistocene age that are from a mastodon that was discovered here. They found the lower jaw, ribs, a wrist, some toe bones so far, and they hope to come back and do some additional work. But this is this mastodon was discovered just last year. And so as part of this work, Bob asked me to come down and show the students there how to collect a core and maybe see what we could find beneath it. So the mastodon is very close to the surface. And the other part of the story is that Bob has tried to radiocarbon date the mastodon, but has been unsuccessful getting a radiocarbon age because he thinks that the bones are so close to the surface that they were weathered, and they do not. They're weathered too much to give a reliable radiocarbon age at this point in time. So he's exploring other opportunities to try and get a radiocarbon age. But in the interim, he'd asked me to collect a core with the students. So I came down there on a lark just to collect a core and show the students how to do it. And as part of that process, we collected a 4-meter core, not too far away from where the mastodon was. And you can see the 4-meter core there laid out. Very peaty wetland areas we might expect, and the black dirt area of Orange County. And then again, so we've got in the upper cores are peat and organic sediments, and they transition from the peat into sort of sapropel, and then into finding silts and rhythmites, so on and so forth. And then the cores were brought back to the State Museum, where we were able to slab them and take a look at them again. On the cores, take a look. So I'll zoom in, and you can see that this bottom around 180 centimeters or so in the core, 170 to 180. You can see there are these black smudges again. If we zoom in, okay, I know what that is. We've seen this before. These look like those plant macrofossils. And in fact, it's more of this tundra plants. That's Dryas on the left, Salix on the right. And again, more of these Dryas leaves, tundra plants. So we were able to collect these and send these off for radiocarbon dating. And lo and behold, again, they came back very old, which we hoped we'd find some older tundra plants, which fits into this story about that deglacial debate, it turns out. So on the side of the right-hand side of the slide, you're seeing the stratigraphic column, which is showing our stratigraphic cores. And really, it's a 380 centimeter, 3.8 meter core. And, at 180 centimeters, we're already back at 18.2 with our radiocarbon ages. So it's much older than I was sort of expecting to find. I was hoping to find, but wasn't sure. But we almost have another 2 meters of core below that, which is, again, probably older. The radiocarbon ages above maintain superposition to tell us that things are stratigraphically probably okay in the cores. So this was really interesting and pretty helpful in terms of trying to understand the site and the site dynamics. If we go back and look at the existing radiocarbon dates to try and make heads and tails out of this, take a look at this paper from 2005 at the Otisville site and compare it with Dorothy Petit's work from 2012 at the Otisville site there again, looking back in the details. Again, Dorothy's primary premise as the delayed deglaciation is that she's not finding plant macrofossils that are really older than about 16,000 calibrated. So the idea is that it's so harsh a condition that there's no tundra plants that are growing on the landscape. Whereas the new tundra plants that we just found seem to sort of suggest that that's not the case. The oldest date that she cites in her work comes from this 2005 paper, which is this calibrated sort of range of 17.4 to 16.8, where they're looking at again. So the new tundra plants that we found from this one site, by chance, kind of happenstance, is really suggesting basically that there's a different or older chronology. And again, going back to the stratigraphy we have, we can pretty safely assume that the base of the core has got to be older, maybe significantly older. We don't really know that 18.2 from these current radiocarbon dates that we've got on the site here. So the base story here is that if the Pellet Island moraine if our core is older than 18.2, then the Pellet Island moraine has got to be, must have deglaciated. It must be older than the information we have on the landscape. So this combination of radiocarbon is helping us to sort of piece together the paleoecological story and the story of early colonization by megafauna and the deglacial dynamics on the landscape. So our next question, or a PDH question here, is which county in New York has yielded the highest concentration of mastodon remains in the United States? Niagara County, Orange County, or Albany County? The answer is choice B, Orange County, highest concentration. And our last sort of case study, again, is some recent work that's come together. This is this map I showed you earlier from Dalton showing the map to our interpreted late glacial maximum. And that square is our study area, which is all the way up in the northern Schoharie Valley. There's our lobes again, which I've talked about before, so I'm going to sort of roll through this. Part of the work we've done with the LIDAR is the ability to identify new sublobes, new glacial terrain, where glaciers must have been flowing we have never been able to recognize before because we didn't have a LIDAR. So we've known that the Schoharie sublobe was a thing from a little bit's been suggested, but this Westerlo sublobe is this new lobe that was sort of a tributary, an offshoot, if you will, off of the Hudson Champlain lobe. There's the position of the Heartwood moraine I talked about earlier. Some of these newer discoveries we're making with understanding the sort of extent of some of these moraines on the landscape. So the northern Catskill study area is, again, right there trapped up between these Middleburg margins and the Rosendale ice margins, which are, again, are constrained to the Varve chronology. Again, we really don't know the age of the Rosendale margin. It's just greater than 1803, so could be significant. So part of the story in the Schoharie Valley is early recognition by early workers that there was a large outlet for a meltwater corridor at Grand Gorge, New York, in the central escarpment of the Catskill Mountains, proposed by Darton back in the late 1800s. And then along this northeastern escarpment of the Catskill Mountains, that was suggested by my predecessors, Don Cadwell and Bob Dineen and some other people, that ice from the Hudson lobe had crossed over this terrain into the Schoharie Valley and built deltas and other landforms trapped in a late glacial lake. And so our mapping was working in this particular area to sort of look at this in detail. And so this is this glacial lake Grand Gorge, which is flowing out to the southeast into the Delaware River at an elevation of about 1,600 feet or 488 meters. Another much smaller lake, really high on the landscape, Glacial Lake Broome Center. And we're trying to understand the ice positioning to create these lakes and their ages and so on and so forth for deglaciation. And these lakes deposit a lot of lake clays, which have been causing landslide problems, which are potentially impacting the reservoirs for the New York City water supply in the Catskills. So that was part of the work that was driving our mapping work in these areas. So again, we're looking to understand, is there evidence to support this Hudson lobe area, stratigraphic evidence of re-advanced history, so on and so forth, and the age of Glacial Lake Grand Gorge were kind of the questions we're going after. And we focus this work on these two primary valleys where the largest deltas are present on the landscape. And again, our LIDAR data really helped us here to sort of map and understand the landscape, primarily in this Livingstonville quadrangle, which was mapped as 2021 project just published last year to identify this area. And again, with the landforms, the glacial landforms, the drumlins primarily, we can reconstruct flow lines to help us understand these new sublobes. So that exercise is something like this where we're mapping all the drumlins, we're mapping the ice margins, and then the landscape, and then trying to move forward, understand the dynamics and the ice and the extent, so on and so forth, targeting sort of more surgically specific landforms, primarily deltas and stuff like that. So here's our ice flow based on our ice flow indicators. And we can see that there's actually an interlobate area of convergence between this Schoharie lobe and our Westerlo lobe, right along this northeastern escarpment of the Catskills. And so there's a number of these large deltas, the Platterkill, so on and so forth. I don't really have time to go through all of them, so I'm just going to sort of highlight in on this lower section here of the Manorkill Valley. You can see there's a morainal bank that was mapped by early workers in the 1930s, John Rich and some other people, as a moraine system deposited by ice, supposedly the Hudson lobe work. Site 3 is an exposure we discovered while doing our mapping work, which is a fluvial gravel stratified system here along the Manorkill River itself. And this exposure, this is a location that's where the OSL sample was collected, stratified with an abrupt contact with a boulder cobble gravel unit. Some of the boulders are over a meter in size, so it was probably ice proximal. And the OSL ages that we received from these sediments were substantially older. In fact, there's numerous ages that clustered very consistently around this 29 to 30,000 year age, which was very surprising to us. We weren't expecting to get ages back on these OSL ages. So this was sort of a, again, significant sort of interesting development with the work we're doing. So we went back from Site 3 further into the smaller basin to the east of the moraine system, Site 4. Again, there's drumlins on the landscape and bedrock striations showing us the ice flow indicators to the moraine. A lot of consistent evidence for ice flow from east to west, so on and so forth. And these sites here were sites we investigated with a subsurface coring using geoprobes, sonic, and so on and so forth to characterize basin stratigraphy. No idea what the depth to rock was. Was there anything in the subsurface we could find to date? And so again, sonic, wireline coring, so on and so forth in these sites. So that's looking west. That's that ice margin I showed you on the LiDAR before on the landscape and with our sonic methods. And so here's our stratigraphy, just rolling through this again, trying to stay on track with time. We did find materials on the subsurface. We kind of, first of all, found a sand unit we could collect another OSL sample from, and you'll notice that the age is almost identical to the age of the stratified sand unit a few kilometers to the west, or less than a few kilometers, about a kilometer to the west. And then above that unit in the sort of base of unit 2, which is sort of a lacustrine fine sand unit, we actually recovered a twig and kind of hit the lottery in this location. And it turns out that that has a radiocarbon age of 21.4, which calibrates to a age of about 25.8, which is the same age as the late glacial maximum, supposedly. So now we're sort of thinking to ourselves, what the hell is going on here? These ages don't really match up with what we know. But the next thing, we went back and drilled another core looking for more organic material, and we didn't find any more twigs, but instead we found insects about 18 meters to 20 meters in depth. We found winged insects that are super, super small. My colleagues thought they were leaves, but under the microscope, you can see the wings. You can see the hairs coming off of some of these other insects. We haven't been able to get these identified, but they appear to be the same. This is one, and then this is a close-up of another one where you can see the wing. So we're hoping to find somebody that can help us to identify what these are exactly. They're microscopic, but where there are twigs and insects about 20 meters down at the base of the core, coming back at these much older ages. So with a whole host of other OSL dates that we looked at on the landscape, collecting a variety of ages, we were able to piece together radiocarbon and OSL chronology. These are all of our OSL ages. The bottom graph is showing you the last glacial maximum ages clustered. And if you take the average of all of the OSL ages, which is the recommendation of my OSL colleagues, sort of look for deviance again, that's at 1 sigma, 2 sigma standard deviation. We can see that there's a group that clusters right around 29,000, and our shallower sediments are clustering at a different location. But the mean or the mean average, the mean age of our OSL ages is identical to the ages for the terminal moraine down in Long Island and northern New Jersey we're looking at. So there's a radiocarbon age. Our radiocarbon age plots directly within the mean of all of our OSL ages, giving us confidence in our OSL ages. And then that's our sort of a lower standard. So we're, again, showing us basically that we're looking at the glacier was here in this valley, and the lake existed pretty much for a time frame between about 21,000 to about 29,000, is sort of guessing where we're at around a 7,000 year duration based upon this preliminary data, the only data that really exists in this region, so to speak. So again, there's overview map of the location in the quadrangle where we were mapping and did this work, our geologic map of the landscape, and the reconstruction we're able to do on the basis of this geochronology is sort of a threefold here. So that this westerlo sublobe is advancing. It's again a tributary glacier sort of off the main Hudson lobe. It's advancing across the eastern divide of the Catskills and then retreating backwards early. It's trapping a very large lake in the northern Catskills around the time of the last glacial maximum. It's building these moraines. And then it's retreating back along that divide, building deltas and feeding sediment and water in to build the deltas based on the OSL ages. And once the ice retreats far enough to the western lobe ice retreats to the east far enough beyond the northeastern escarpment, it can no longer contribute sediment and melt water into build the deltas. And then materials and building new landforms and a new landscape to the east of the divide. So this is sort of our reconstruction on the basis of our mapping, what we're working on again. So the last question, a bonus question, Is which type of glacial landform can be targeted for this age dating? Moraines, drumlins, deltas, or both? And our choice is actually, our choice is not B. Our choice is actually going to be D, which would be A and C. Deltas and moraines, we can target for basically age dating. So that's my bad. I apologize on that. So with that, I'll end the talk for right now and take any questions. And hopefully I didn't go over too far. Again, thank you for your time and the ability to come and present some of this new data.
Thank you. Thank you, Andy. Let's see. I'm gonna go scroll up and see what kind of questions we have.
Oh, I've got okay, go ahead.
No, Chris, go
right.
right for it.
All right. Well, I extracted a couple as they went on. Thank you, Dr. Kozlowski. That's been an excellent presentation. I hope everybody could follow it. It was wonderful. The first question I have here is from Stephanie Rosenberg, and she asks, how do you find the atmospheric C14 or carbon 14 for calibration?
That is an excellent question. And the answer to that is with dendrochronology. So they were able to use tree rings to basically go back and measure tree growth and establish a calibration curve. And so it's a combination of this really excellent scientific detective work using dendrochronology to basically reconstruct what the C14 fluctuations were in time. So they were able to reconstruct this record of tree rings back that far to sort of gauge it. And in about every 5 to 8 years, that calibration program gets a new update and it comes through and they'll get more information and it will become more refined as they're getting older material that there's trace amounts of radiocarbon datable material. So it's done with dendrochronology. That's my understanding.
Great. The next question is from Amy Marie, and she says, I do not understand how the plant macrofossil gives you a minimum age of the basin. What if the tree is really old, parenthetical 100-year-old tree, and then the tree falls down into the basin? Carbon 14 only tells you how old the tree was when it fell down. How does that relate to the basin?
Another excellent question. Thank you. So it is a bit of a detective story in the sense of how you're doing it. So again, what really helps us with our stories, if you have multiple things to radiocarbon date, again, good science is repeatable, right? So if we have multiple radiocarbon dates, we can use that to infer what the age is. The other thing is that durable items, in your example, if it's a tree or a piece of wood, the wood can survive on the landscape and get reworked and retransported and redeposited in a basin. So you have to be aware and kind of sort of looking at the stratigraphy and the radiocarbon dates and considering the possibility if it's been reworked. If it's wood, it's absolutely a possibility. The plant macrofossils really can't handle being transported that far. They're too fragile for the most part. So they're not getting the same kind of a transport path into the basin. And again, it took me a while to sort of think about that, but you have to have the depression to have it form a pond or a lake early during deglaciation. So you have to have a depression that can accumulate the sediment, and the fossils have to be able to wash into the landscape. And so you have to deduce using, again, the radiocarbon data you have to estimate that age. And then you can develop, if you have enough radiocarbon data, you can develop a sedimentation rate that's specific to the basin. And then you can project the sedimentation rate to the base of the core, and that will give you a projected age at the base of the core. But the radiocarbon dates are really used in that situation to give you this minimum age for the basin. So the basin could have been a lot older and stuff could have washed in, but it's a minimum age, sort of speaking on the basis of the radiocarbon ages.
Great. Does anybody else have a question? I'd like to come off mute and ask it directly. I'll say, Dr. Kozlowski, I certainly have a great new trivia question about Orange County and Mammoth, so I'm going to use that at parties.
Did folks know that? I mean, I thought maybe it's common knowledge. I was surprised. I didn't know that.
I did not know that.
If you're working down in that area on some of your sites, keep your eyes peeled. It's a fascinating landscape, and there's tons of great stuff still buried in that black dirt and in those areas down there. Discoveries to be found for sure.
I want to say thank you as well. I did not know that either. So I found this pretty fascinating. I hope that everybody else did too.
I would just add that a lot of it is, I think a lot of it is luck. I'm showing you highlights sort of the work we've done where we found cool stuff. We miss a lot. Like you go out and you look and you search and you go and you core wetlands and you find things, and sometimes the plant fossils are not there. So I sort of showed the highlights, but we miss a lot too. But it's when we do find stuff, there's lots of new discoveries, lots of new things to learn still about the geology of New York.
Well, you have this screen up that says thank you for your time to us, but really thank you for your time. I appreciate it.
Yeah.
This is
Very
great.
glad to present. Thank you.
We appreciate it, and we hope that sometime in the not too distant future, you'll come back and share more with us.
Glad to do that.
Awesome.
All right. If there's no other questions or anything, then I'd like to say goodnight to everybody and thanks again.
I don't want to hold anyone up, but I was wondering, you mentioned you're looking for someone to help identify the bug. I might have somebody for that. If so, how should I find you or reach out to you?
You can go to the New York State Museum, our website under Research and Collections, or contact the staff, and you can just email me. And some of your colleagues there might have my email address too. I welcome anybody that is willing to sort of try and lend a hand with that. They're pretty cool. We'd like to know what exactly they are.
Awesome. Yeah. I mean, if my friend can't help, I feel like they'll know someone who can. So hopefully I can send someone your way.
Excellent. Thank you. That'd be great.
Awesome. Anything else? If not, we'll sign off. And again, thank you, Doctor, for presenting this. It was certainly
You're very welcome.
interesting.
My pleasure. Thank you again.
All right. Have a good night, everybody.
What a